Hello, my name is Angel Barracin. I am a student of mechanical engineer. This is a presentation that we're going to talk about and is an introduction to hydrostatic pressure. And this is for the signature of mechanical fluids for the engineer Héctor Augusto Sam. That is a professor in the University Fundación Universitaria de los Libertadores. So we're going to become with this topic. Well, we have that the hydrostatic pressure is stirred by a fluid at reset, such as water or air. On a surface, this pressure is fundamental concept in fluid mechanics with widespread application in engineering, physics, and everyday life. So in this presentation, we're going to analyze what are the topics that are more related to this, and see some basic concepts and different topics related. Well, we have the first the hydrostatic pressure on flat surface. Hydrostatic pressure is the pressure exerted by external liquid on a flat surface, submerged in it completely or partially. This pressure acts perpendicular to the surface and increase with depth. In other words, as deeper that the surface is, the more pressure that we are going to have. As described by the hydrostatic pressure formula, and we can say that understanding this principle is crucial for designing structure and equipment exposed to liquids. This is kind of more the aerostatics, like when they generate the electrical aerostatics that replace the water. So that is the principal example that we have in this situation. Well, here we have some tools that we can use to we have the pressure of a system or environment. In this case, we have manometers. We're going to know the principles and applications. The manometers are devices that used to measure pressure, particularly the difference between two pressure points, and operates the principle of hydrostatic pressure, where the head of a liquid column corresponds to the pressure difference. Manometers can be measured both positive and negative. The negative is the denominated vacuum, this pressure with high accuracy. And they have the common types like the U-tube and digital manometers, while using industrial process, systems, experiments, scientific experiments. And we have the application measuring gas, liquids, or vapor pressure in tanks, pipelines, and machines. So this is like we used to measure the pressure. And well, later we're going to explain what is the difference like manometer pressures. Like we talked about before, they have the vacuum methods measuring negative pressures. And like the name says, in vacuum. So vacuum meters are essentially instruments for precisely measuring negative pressure or such in a wide range or industrial and scientific applications. This advanced device utilizes various principles of quantify the degree of pressure below atmospheric levels. In our accuracy monitor and control low pressure environments, and we have the measure that we have in a vacuum is not too high. It's kind of low. So because we cannot have a lot of vacuum in a system, it's no physically it's not possible this situation. Well, we have here the absolute, manometric, and atmospheric pressures. We have the atmospheric pressure, the summary of all the pressure that we have in a system. For example, is all the general. Manometric is the pressure that is in a specific point or between two different points. So this is more specific, just in a specific system. Maybe we have a pressure on the system and in the environment is another pressure. Then here comes the atmospheric pressure. This is the weight, the height that have the air on the atmospheric, on the system, on everything in our lives. And we have the atmospheric pressure that we can consider like is 1,300 pascals is the most common unit that we can use here at talking about pressures. So yes, this is like the pressure. The relationship between this kind of pressure, we have the absolute pressure, is the summatory, the manometric pressure plus atmospheric pressure. Using this relationship, we can get any pressure. Maybe if we have the atmospheric And the absolute, but we don't have the manometric, we can play with maths and get the complete the pressure that is missing. We have here some graphic representation about the pressure types, like absolute pressure scale, manometric pressure. So we have like examples, different kind of tools that we can use to measure this pressure. We have here the relationship between the manometric and the absolute pressure. We can see that in the relationship, the yellow one or the kind of orange is the manometric, while the blue one is the completed absolute pressure. So we can see that is a difference. So that means there is another environment that is atmospheric who makes the difference in this situation. Well, we have here this part that is more about calculus, is calculating hydrostatic pressure on surfaces. And we have the hydrostatic pressure equation that is equal to capital P, that is equal to density, gravity, and the height, or the deeper that we located the point that we're calculating. And we have the pressure at different depths. The hydrostatic pressure increases linearly with the depth, like I mentioned, and as deeper that we are, as the more pressure that we're going to get. We have also calculated force on surface by multiplying the hydrostatic pressure by the surface areas. You can determine the total force acting on the submerging completed or partial flat surface. Well, we have how we can select appropriate pressure meters devices. We have oscillation. In this, we have to analyze should the pressure goes based on the specific pressure range that we're going to get, accuracy and resolution required for the application. Considering those factors, like working with fluids, temperature, and mounting requirements. We have transferred options, utilized pressure transfer for electronics, signal out, maybe more something more classic. This is more depending about the situation. With sensors, without sensors, more like technology or more common. It is according to the system and the necessity that we have in the situation. We have also to analyze the manometer versatility. The manometer provides a simple relative way to measure pressure visibility, saying we only to select the right manometer type, such as shear tube or incline, based on the pressure rank and precision we need to this measurement. We have some troubleshooting and maintenance of pressure instruments. The proper maintenance of troubleshooting of pressure instruments are crucial to ensure accurate and reliable measurements. They include a regular calibration, inspecting for wear and tear, they properly address any issue that arise. Common troubleshooting techniques include checking for leaks, problem power supply, and explaining sensor connections. This is more like specific for a company or industry that be related in this topic to make the troubleshooting and the maintenance of these pressure instruments. There is nothing that we can do by our end. Have to be a professional doing that. We have seen some partial application of these hydrostatic and case that we can study. We have to study hydrostatic power generation, like I mentioned at the beginning. We also have submarine ballast test control, autotech machinery, medical diagnostics, and the manometer that can help us to different kind of pressure that we have in the medical. And all about the pressures is specific with the hydraulic machinery. I mean, this is like so essential. So this is kind of different points. So, well, this is all the presentation about this topic. So I really hope you have a good rest of the day. Thank you for being here, paying all the attention that you paid here watching this presentation. And I really hope we can see you next time. Thank you.